Hey everyone, myself Bhavya Goyal, a student at IIT Gandhinagar. I welcome you at CodeChef and let's have a look at this question. So yeah, today's question is XOR sorting. In this question, we're given an array A of length n and we need to find and we define f of A to be the smallest non-negative integer k such that A can be sorted in ascending order by the following operations any number of times. So in one operation, we can choose an index I and swap A of I with A of I plus 1 if and only if A of i's or A of I plus 1 is less than or equal to k. So let's say we choose our I to be this 3. And so we can swap this A of 3 and A of 4 if and only if A of 3 or A of 4 is less than or equal to k. And we need to sort the whole array in ascending order. So after all the swaps we did, if for all the swaps the A of i's or A of I plus 1 was less than or equal to k, we can say that the array can be sorted. So f of a is defined to be the smallest non-negative integer key such that the array A can be sorted in the ascending order given these two conditions have to be satisfied. So now in the question, we are given two integers n and k and we need to find an array A of length n which satisfies the following properties. So that is f of A is equal to k. So for the array we are finding, the minimum or the smallest non-negative integer that is required to sort the whole array is exactly equal to k. We are given that all the A of i's will lie in between 1 and n. So each A of I is in between, is an integer in between 1 comma n. And none of the elements are equal. So all A of I are distinct. So these two conditions tells us that A has to be a permutation, right? Because all the elements are distinct and each element is in between 1 and n, so it has to be a permutation of size n. And if there exists multiple solution, we can just print any of them. And if no solution exists, we need to print -1. Now let us look at the sample input ones. So in the first input, we are given 4, 0. So the minimum value to like the minimum XOR which we can have. So like A of I, XOR A of I plus 1 has to be less than or equal to 0 for all the swaps that we are doing. So one possible solution for this is 1, 2, 3, 4, because in this we do not need to do any swaps, and because we don't need to do any swaps, the required value of k is 0. So this is one possible valid answer. In the second input, we are given 2, 2. So for this test case, the only possible permutations which we can have is 1, 2 or 2, 1. In this one, the value of k is equal to 0 because we do not need any swaps. In this one, the minimum value of k required would be equal to 3 because we need to swap them up and 2 or 1 is 3. So we can see that for k equal to 2, no valid answer exists. So the answer is -1. Now let us look at the third test case. So we have 5, 4. And for this, let's just verify that this permutation, this answer given is a valid answer. So we have 3, 2, 5, 1, 4. We can swap these two elements. 5 or 1 is 4, which is less than or equal to 4. So these two can be swapped. Now we can swap these two elements as well. So 5 or 4 is 1. So this can be swapped. Now we can swap these two elements because 1 or 2 is 3. So we'll have 1, 2. We can also swap these two elements because 1 or 3 is 2. So we'll have 1, 3. And we can also swap these two elements because 3 or 2 is 1. And we can see that the whole array is sorted with all the ZORs less than or equal to k. And hence, this is a valid answer. And also notice that the value of k cannot be less than 4 because 5 or 1 was 4, so it has to be at least 4, right? And yeah, that is pretty much the test inputs. Now let us move to the solution. So let's make a few observations first, right? So first of all, when are we swapping A of I and J, right? So if let's say there is some arbitrary element A of I and there is some arbitrary element A of J, so when like will they ever be swapped with each other or not? So if that element is an inversion, it will be swapped, right? So it's a basic property of it. So for some I less than J, A of I is greater than A of J. So let's say we have something like 2, 3, 4, 1. This two and this one have to be swapped at some point, right? Because it's an inversion. So so some there would be a point when they would be adjacent and they need to be swapped so that the whole array becomes sorted, right? So a pair A of I and A of J will be swapped if it is an inversion, right? Otherwise, if like let's say we have 1, 2, 3, none of them will ever be swapped, right? Because there is no inversion. So for any pair I comma j, if I is less than j and A of I is greater than A of j, then those elements will be swapped, right? So for our condition to be true, right? For the f of a to be equal to k, these are the two satisfactory conditions. So what is the first condition? So there must exist at least one inversion such that A of I XOR A of j is equal to k, right? Otherwise, if there is no element with this equal to k, that means the answer could be either less than k or the bigger than k, right? So there must be at least one pair such that A of I XOR A of j becomes exactly equal to k. And all the other inversions must have A of I XOR A of j less than or equal to k, right? Because if it becomes greater than k, then the overall inversion, then the overall f of a will be greater than k, which we do not want. So all the inversions must have A of I XOR A of j less than or equal to k. And there must be at least one inversion such that A of I XOR A of j is equal to k. Otherwise, f of a would become less than k, right? So if all of them are less than or equal to k and there is no element with equal to k, so that means f of a would be less than k, right? So these two conditions must be satisfied, right? Now let us try to construct a possible pair, right? So let us try to find some pair in a permutation x comma y such that x or y is equal to k, right? Because this condition needs to be satisfied. So let us try to find some pair and we can easily find this pair by iterating from 1 to n and keeping our x equal to this I and keeping y equal to n XOR, sorry, k XOR I, right? We can easily find x comma y pair and if this y is in between 1 and n, that means this x comma y is a valid pair, right? So we can easily find a pair like this in big O of n time. Now let us say we have found such a pair. So let us try to construct a possible answer. So one possible construction could be we put all the elements from 1 to x minus 1 in the beginning. So these all are already sorted and I just literally do not care about all of them. Let us place all the elements bigger than y in the end. So all of these elements are sorted and we just don't need to care about them. And let us place y before x, right? So, and let us also assume that x is less than y. I mean, it doesn't really matter. If it is not, we can just swap them up anytime. Now, if we put y here and x here, so this is an inversion, right? Because y is greater than x and this I is less than this j, right? So these two elements have to be swapped, and if these two elements will be swapped, then y XOR x is equal to k. So we have found exactly one pair which will be swapped. So the answer, like there exists some pair which is equal to k, right? There exists at least one pair, one inversion, such that their XOR is equal to k. Now we also need to ensure that it is like the for all the pairs, the XOR is less than or equal to k, right? So for all of them, we just don't need to swap, so it doesn't matter. X will come here, Y will come here after the swap. So this much part is sorted, this much part is sorted. So we are pretty much sorted on these parts, right? But what about all the elements in between X and Y, right? Okay, it should be Y minus 1. So how do we care about these elements, right? We still need to put these elements inside our answer, right? So my claim is now for to construct that, I'll make a claim that is for any z in between this range, either z or x would be less than or equal to k, or z or y would be less than or equal to k, right? Because we need to put these elements in a way such that their XOR with something is always less than or equal to k, right? And to prove this claim, let us say that x is of some of this form and y is of this form, and this is our k. And we have x XOR y is equal to this k, right? This x XOR y is equal to this k. So for some initial bits, all of them would be equal, right? Because k have 0 at all of these places, right? Because k has 0, so all of them have to be same. Now x is less than y, so there would be a bit where this would be 0 and this would be 1 and our k would be 1, right? Let us call that bit as b and after that there could be anything. right? There could be 1, 1, 0, 0, 1, 1, and there could be any arbitrary numbers, right? So from x plus 1, x plus 2, dot, 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 some b minus 1, we'll have there this b as 0, right? So this b is 0, and this will be true up till some point. So for x, this bit is 0. For x plus 1, also maybe this bit is 0. And up till some b, this bit would be 0, right? So for all of those numbers, what would be XOR that z, right? So this bit is 0 in x. This bit is also 0 in all of these numbers. So this bit will be 0 inside their XOR as well, right? And because this bit is 0 and in k this bit is 1, this whole XOR would be less than or equal to k, right? Similarly, for all the elements from b to y minus 1, all of them would have this bit as 1. All of these bits would still remain the same. This bit would be 1, right? This bit would be 1 for b to y minus 1. And if we do the XOR of them, if we do the XOR of y with these bits, all these numbers, then that would be less than or equal to k, because this bit would become 0. All of them are same, which would be exactly the same as them. And after that, whatever doesn't matter, right? Because this is 0 and this is 1, so this XOR would be less than or equal to k only, right? So now let us try to create another construction, which is this. So we have 1, 2, 3, dot, 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 x minus 1, as we had earlier over here, right? We'll have these elements still the same. So y plus 1 would be still the same. Yx would still be the same in the center. And we'll put x plus 1, x plus 2, dot, 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 b minus 1 here, and b plus 1, dot, 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 y minus 1 here. So what will happen this way is the XOR of these two elements is equal to b. So we'll swap them. We'll have x here, y here. So we have exactly one pair, at least one pair, such that the XOR is k. And now the XOR with all of these elements would be less than or equal to k. So we'll swap them up. Then x would be here, b minus 1 would be here. Then we'll swap them up and we can similarly sort all of them. And for all these pairs, the XOR would be less than or equal to k, right? And similarly, for all these pairs, right? Y XOR b, y XOR b plus 1, y XOR b plus 2, dot, 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 y XOR y minus 1. The XOR would be less than or equal to k, right? And because these two conditions are satisfied, there exists at least one pair such that the XOR is k. And for all the other pairs, the XOR is less than or equal to k, and we are able to sort the array. So the minimum f of a, minimum required value of k to sort the array would be equal to k only. And this way we can construct one possible array. Now the time complexity would be big O of n only, right? And another implementation detail. So while implementing, we do not really need to find what this element b is. So this b could be some arbitrary element. We know that either this is going to be true or this is going to be true, right? So we can check if my number x or z is less than or equal to k. If it is, I'll just put it in some left array, or I'll check if my z or y is less than or equal to k or not. If it is, I'll put it in some right array. And then while printing my construction, I'll print 1 to x minus 1 elements first. Then I'll print the left array. Then I'll print y, then x, then the right array, and then all the elements from y plus 1 to n, right? And this way we can just print our full construction. And if we're not able to find any possible pair, right? If no pair exists such that x or y is equal to k, our answer would be simply minus 1, right? So that's pretty much the whole solution. Now let us see the code in C++ and Python. So this is the solution in C++. So we'll run a loop for each test case. For each test case, we'll take in the input of n and k. Now we are directly printing the permutation from 1 to n if k is equal to 0, because we know that that is one possible answer. So we are considering this edge case separately. Now we're trying to find some possible pair such that x or y is equal to k. Now if y is in between 1 and n, that means we can create a valid answer using these x and y's. Now we'll define a left vector and the right vector. We'll run a loop of z from x plus 1 to y minus 1. And if x or z is less than or equal to k, we'll push it inside the left array. If z or y is less than or equal to k, we'll push it inside the right array. Otherwise, this condition can never happen because we proved that either z or x would be less than or equal to k, or z or y would be less than or equal to k. Now we'll create an answer array. So we'll push in all the elements from 1 to x minus 1. Then we'll put in the whole array L. Then we'll put y and x. Then we'll put the whole array right. And then we'll put in all the elements from y plus 1 to n. In the end, we'll just print our answer and return. So that's pretty much the whole solution in C++. And if you're not able to find any element, we'll just print -1. The time complexity is big of n. Right. Now let us see the solution in Python. So we begin by taking in the input of n comma k. If k is 0, we'll just print all the elements from 1 to n. So we're just separately considering this edge case. Now we'll run a loop from 1 to n. If y is equal, yeah, we can just find the y to be XOR k, and if y is in between 1 and n, that means this x comma y is a valid pair. We'll define a left and right array. So we'll run a loop from x plus 1 to y minus 1. If x or x is less than or equal to k, we'll put it in the left array. Otherwise, we'll put it inside the right array. And this condition can never happen because we have proved that either x or n would be less than or equal to k, or y or z would be less than or equal to k. So if this condition is happening, that means there is something wrong going on with the implementation. Now we'll construct our answer array. So we'll put all the elements from 1 to x minus 1. We'll put all the elements of L. We'll put all y. We'll put x. Then we'll put all the elements of R. And then we'll put all the elements from y plus 1 to n. And in the end, we'll simply print our answer. And if no such x comma y pair exists, we'll print -1. And yeah, that's pretty much the whole solution. The time complexity of this again is big O of n. And yeah, that was the whole solution. I hope you liked it. Thanks. Bye-bye.